All right, thank you, Ken. I'd like to call our next group up to the stage. Next group is going to be 4 of our engineers that will be presenting what's in the TxDOT design manual and how do I use it. These 4 individuals have worked over the last few weeks to gather a lot of good information on how you will use the design manual to set some criteria, and they're going to go through this as a group effort. So really quickly, I'm going to introduce them. We have Travis Hajek from the Design Division, Chris Graf from Brownwood District, Curtis Hanan from the Fort Worth District, and Michelle Millard from the Houston District. Travis graduated from Texas University in Austin in 2002 with a Bachelor of Science degree in Civil Engineering. He obtained his PE license in 2007. Then he began his career in Field Section B of the Design Division before spending a 3-year rotation with the Project Management Office in 2009. Although Travis went to Texas University, he wanted to say that he has a lot of friends that are Aggies, and he was glad that they covered the point spread this weekend. So, yeah. Chris graduated from Texas A&M University in 2006, and he started his career with TxDOT in the Brownwood area office, working on design and construction projects. He became the Brownwood District Design Engineer in 2013 and is also currently serving as the interim Eastland area engineer. Chris and his wife Tony live near Brownwood, where they're raising their 3 daughters, Casey, Erin, and Jaden. We also have Curtis Hanan, who began his TxDOT career in the Fort Worth District Survey Section. He worked there during the summer months of '87 and then returned in '86 and then returned in '87 as a construction inspector. Continued working part-time while he was finishing college at Texas University Arlington. After graduating with his Bachelor of Science in Civil Engineering in '88, he was promoted to being an engineer assistant and assigned to the laboratory in the Fort Worth District. In February of '89, he began working for Mr. Burton Clifton, reviewing and developing freeway schematics in the advanced planning section. He then graduated with a master's in public administration in '94 from the University of North Texas, and he has served the Fort Worth District Advanced Planning Project Development Director since 2004. He also spent some time supervising their toll office through 2006 and 2009. Finally, we have Michelle Millard, who is 30 years of experience with the civil engineering field, including transportation projects in Pennsylvania, Florida, and Texas. She earned her Bachelor of Science in Construction Management from the University of Houston and was licensed in Texas in 2002. For more than 21 years, she's worked in the Brazoria area office of the Houston District in various roles, and she was named the Brazoria area engineer in 2016. Michelle's also had a career with the United States Air Force Reserves and Air National Guard for 21 years, including multiple overseas tours.
Max, do you have the clicker? So Max obviously went to A&M, and yeah, he has to call it Texas University, but if you go to school here, you forget the clicker, right? Just kidding. Okay. All right, well, thank you all for joining us, and then thanks to Ken for getting the talk started on the Roadway Design Manual. Certainly pleased to see so many people showed up here to have a talk about the Roadway Design Manual. Now, don't worry, it's not just going to be, obviously the title there says, what's in it, how do we use it? I'm not just going to sit here and read off, just numbers out of tables. Y'all can do that yourselves. In fact, I see a lot of people with their phones out. You could actually right now do a Google search for the Roadway Design Manual and pull it up and kind of follow along if you want to, or check your fantasy football team, whatever you prefer. So anyways, let's get started here. First of all, this was a very large collaborative effort. There's a lot of stuff in the Roadway Design Manual. So obviously our panel here and our co-chairs had a lot of input from people in Design Division. Now you also notice we got FHWA, Bridge, Traffic Ops, and TPP on here, and that's because the Roadway Design Manual, by reference, brings in probably at least 20 other manuals. Now we have limited time here, so we can't talk about all those other manuals, but there are a few examples in here where we thought it was appropriate to mention what else might be applicable to roadway design. And so here's kind of an outline of everything we're going to go through. Start out with some general guidance, and then quick discussion, 4R versus 3R versus 2R, then frontage roads, access control, collector distributors, horizontal and vertical alignment and clearance, ADA accessibility and bicycle facilities, although I'll mention Pete Krause later today is going to do a separate presentation on that, but he did give me a few things to mention right now. And then preventive maintenance and off-system bridge replacements. And if we have time, we'll get into some bonus content there, FHWA bridge, traffic, etc. Now, again, I said I didn't want to, just take screenshots and read through what's in the manual, although the preface to the manual, and this is kind of like what brought about the necessity for having this presentation. So let me just go ahead and, again, I promise it's the only part of this I'm probably going to read word for word, but it's important. While much of the material in the roadway design manual can be considered universal in most geometric design applications, there are many areas that are subjective and may need varying degrees of modification to fit local project conditions. The decision to use specific design guidance at a particular location should be made on the basis of an engineering study of the location, operational experience, and objective analysis. Thus, while this document provides guidance for the geometric design of highways and streets, it is not a substitute for engineering judgment. Further, while it is the intent that this document provide geometric design guidance, the roadway design manual does not represent a legal requirement for roadway design. So again, we're going to emphasize that, yeah, there's a lot of parts of the manual that use subjective language that allows for engineering judgment. So that's really what we're going to be talking about, again, as opposed to just the numbers in the tables. Now, important thing to note here, when you make decisions that are project specific and might vary from normal practice, then you want to maintain good documentation of those decisions. Also, if you're doing anything that requires, and Ken covered some of this, the updates to design exceptions and waivers and variances, if you're doing one of those, then make sure, get those processed. Again, remember, y'all are doing that within the districts. We used to handle that in the divisions. Do that as soon as you can. And when in doubt, please ask design division if you think that you might need to do one of those. We'll help you out. Okay, so first of all, we'll start here just with some general guidance. So the very first thing, again, just as a reviewer, the very first thing I do when I receive a plan set, schematic, et cetera, I go check the statewide planning map, and we have a hyperlink there, and there's tons of hyperlinks in here to help y'all out. And that's going to tell you things like specifically those first two, functional class and then urban versus rural, because those will dictate what type of design criteria that you're going to need. And it probably, unfortunately, it probably happens more than it should, is I got 100% PS&E in front of me, and it has either the wrong functional class or they're calling it urban when it's really rural, or vice versa. So again, before you start making decisions about design criteria, please check this map. Now, another thing is, like I mentioned, that we got some input from TPP. So one thing that they wanted us to mention about this, it was actually a question I had for them, was, well, let's say the map currently says that something's a collector, but I've got a 1002 that calls it an arterial, and maybe that's correct. So what is the process for districts to get this map updated? And the answer is either through coordination with FHWA and or an MPO, the map can get updated. So just so y'all know that if you ever are using this map, and again, if you know that something's now an arterial, but it's being shown as a collector, then that's the process you got to go through to get it approved and get it updated. And then you can see there's a few other things on the map there, different layers. It's pretty interactive. And again, that's linked right there. And most of the links on here are accessible, even if you work for a consultant and you do not have access to our internal network. Most of the links on there, unless noted as part of Crossroads, you should be able to get to those. Next thing is designing above minimum standards. We see that sometimes too on projects, to where either to save money or for whatever reason you're designing just to the bare minimum, because a lot of the design tables have a minimum and a desirable value. And again, here just some quotes from throughout the manual. Again, I'm not going to read all of them, although that very first one is worth reading here. Use of higher than minimum design standards results in a driver environment which is fundamentally safer, because it's more likely to compensate for driver errors. So that's really, that ought to be the first thing that you're thinking about if you're considering using the minimums out of every table, is that, are you creating something that's fundamentally going to be less safe? And we may even comment on it, even if the table says, yeah, you're allowed to do this as a minimum, we still might encourage you to do something higher. Okay, planning for the future. Depressed medians. So now I put together a little animation here to show 4-lane divided rural, and so there's a discussion in the manual about what happens when that's going to turn into a 6-lane, and you might close it in the middle. First of all, make sure when you're constructing your 4-lane divided that you're leaving sufficient room to add an extra lane or 2 lanes, plus a shoulder, plus a CTB. And then that second bullet point there, again, that's what that animation is kind of showing, is that depending on, let's pretend it's, the animation is kind of showing both alignments going through the same curve. So they're both going to have super elevation in the same direction. Now, the vertical elevation of both alignments, if they're pretty close to being the same, you can see what the animation is doing there. You're probably going to have some type of retaining wall in the middle. Whereas if you plan it ahead better to where they are kind of offset, and they would eventually end up being on the same super elevation plane, then you don't have to spend, again, it's going to come down to spending extra money to do retaining walls. So just keep that in mind. A little advice on freeways: establish access control at all your ramp terminals and intersections in areas with, and then in bold there we put and without frontage roads. And there's a discussion, RDM Chapter 3, Section 6 on that, as well as a reference to the Access Management Manual, Chapter 2. And so what that's emphasizing there is like, okay, let's say I'm building a rural freeway right now, but at some point, hey, it may become urban. I might need to add frontage roads, but you are encouraged, if you're submitting a schematic for that, go ahead and show your access control lines, even if there's no frontage roads there. Again, just trying to plan out where you think ramps and intersections or driveways are likely to be. You can show that on a schematic, even if you're not constructing it with whatever the current phase of development is. A few more things here. Planning for the future in a developing urban area. Make considerations to accommodate future pedestrian and bicycle access. And later on, like I said, we'll have some discussion on that. Also include sidewalk consideration in culvert designs. And then that next one is also about structure design. Could apply also if you have a structure, okay, maybe right now there's no need for sidewalks or a bike lane. You could consider that in your bridge deck width. There's a screenshot actually of it's a partial interchange that's near my house in Austin. But you can tell right there, the way it's striped, there's just one lane going through this very wide bridge deck right now. And the reason for that is that further upstream there's a place for a future direct connector to come in. And I believe that's actually under development right now. But that was constructed probably close to 10 years ago. So it's just been sitting there waiting for that extra connection to come in. And so again, they won't have to do any work. This is planned out very well. They won't have to do any work to modify that bridge. They're just going to add the direct connector. Then down there at the bottom, when you have different consultants, we were actually just talking about this during lunch, when you have different consultants that might be working on your schematic versus your PS&E development, maybe some consultants in the room have experienced this, is that perhaps the district, they didn't pass on to you. Let's say you're doing the PS&E. They didn't pass on to you a copy of the schematic developed by the other consultant, or maybe the design's changed so much to where the schematic is irrelevant, but that may not have all been passed on to you. So we just encourage the district to make sure, maintain good documentation, share as much information as you can if you have a different consultant doing your PS&E compared to the schematic. Because again, we've seen that a lot, to where we have, and again, design division, we maintain all the schematics. Until a project lets, we probably got it in a cabinet somewhere, and it happens, again, one of those things happens more often than it should, to where I've got my 100% PS&E, I've got a schematic, I'm comparing them, and they're not alike at all. And again, there may be reasons that that's okay, but that information was not shared with us, and in some cases we've seen, it doesn't appear it was all shared with the new consultant either. Also, something else that came up during lunch, and we may not be able to get to this, the slide at the very end talks about some tips on PS&E, but it's kind of relevant here, is that if there are these types of changes during project development, specifically related to either project limits or the scope of work, be mindful of what that might do to the STIP status of the project and the NEPA document. Because we are, many of y'all probably know this, we are submitting a monthly report to FHWA for each letting on the STIP and NEPA status for these projects. And so to minimize delays because of that, again, be mindful as you're developing your project, follow up with TPP and environmental division when you think that you might have something that could potentially change your STIP or your NEPA. And now I'm going to turn it over to Michelle to talk about turn lanes and medians.
Hey, so in Houston, south side of Houston in Brazoria County, I've started there in the late 90s, and it's a pretty rural county. We had corridors that had a lot of two-way left turn lanes. And at this time, the county is growing, it's developing, and raised medians. We're replacing most of those two-way left turn lanes with raised medians. So thinking for the future, look at your two-way left turn lane design and provide enough room to transition those to raised medians in the future. So where are those thresholds? So 10,000 or less ADT, driveway density of about 10 per mile. A two-way left turn lane is appropriate design for that. But as your corridor develops and you reach 20,000 ADTs and like 20 driveways per mile, the crash rate increases, your congestion levels get higher, more delays. So a raised median in that case serves a good purpose there and reduces crashes. Our partners here at TTI have done a lot of research on access management, and you can reduce your accidents between 30 and 70%, and I'm a firm believer in that. Now, if you design for that, you can make the transition a whole lot easier, a whole lot quicker. Those transitions to raised medians are not popular. The public has a lot of things to say about that. A lot of that I can't repeat in here. However, from Hurricane Harvey, the silver lining we heard earlier, there's 3 people that have thanked me for those raised medians here recently because they used them to keep their cars out of floodwaters, and they saved their vehicles. So silver lining in that. So when you do the raised medians, the other thing you need to look for is for pedestrian refuge. And so you need at least a 6-foot width median to serve as a refuge for pedestrians. And if you have ramps proposed, you need to have the appropriate width of a median to have the 5x5 landing, as well as room for your slopes from your curb heights.
All right, thank you, Michelle. All right, continue now with some general guidance. Design speed considerations, again, just observations that we've seen. This first one comes mostly from schematics, to where you'll call out a design speed, say, for example, 70 miles an hour, but you've got a spot in there, vertical curve, let's say, that only meets 50, but provided done no design exception or any other documentation about why that is. And there may even be, sometimes we'll see there's even a table that calls out at any given curve or change in the alignment. It's sort of like a design speed table, and you really don't need that. Like whatever alignment that you're designing, you should have just one continuous design speed on it. And again, if you have an element that does not meet the design speed, then you should process a design exception or a design waiver. Now, one exception to this, at second point there, is that if you're crossing from a rural section into an urban section, higher driveway density and those types of things, maybe a two-way left turn, then yeah, you can reduce the design speed in those types of transitions. Hierarchy, your main lane design speed should be greater than your ramp design speed, and that in turn should be greater than your frontage road design speed, and the ramp guidance on that is in table 3-20. The lowest threshold would be the ramp has to be at a minimum 50% of your main lane design speed, although again, that's one of those things, don't always pick the minimum. Like if the main lanes is 70, don't always pick the ramps to be 35. If you can design the ramps to be 50, 60, something like that, that's better. And then frontage roads should be no less than 30. Next thing, again, something else that's come up on a few schematics, be mindful if you've had discussions with either FHWA or a local government regarding a proposed design speed. For example, we've committed to making a stretch of Interstate 70, but then you submit a schematic and parts of it only meet 60. Then, and sometimes districts don't even, they might get a little frustrated with us even pointing that out. And it's like, well, we didn't design it, we just see these things, and if you made that kind of commitment, then you probably want to go update the schematic to make sure that everything meets 70 miles per hour. And then that last point there, again, is another hyperlink to FHWA's website talking about it's sort of a clarification on design speed versus posted speed. So just a quick quote there, anticipated operating speed and posted speeds should be considered in the selection of the design speed, although it goes on to say that there is no direct correlation. And in fact, if you do have a design speed that's lower than a posted speed, that's not necessarily considered to be unsafe, although again, we should always strive for everything to be higher. Okay, mixing design criteria. I think, Chris, you're going to cover that. Go ahead.
Yes, so it is perfectly appropriate in some cases to mix the design criteria within one project. An example of that would be if you're converting a undivided roadway to a divided roadway. The new roadbed, of course, needs to meet 4R criteria. The old roadbed, if you're using that for one direction of traffic, that can meet 3R criteria. Another example we had in the Brownwood District, bridge replacement project, had a 2.5-foot cut in the vertical at the structure to increase vertical clearance. And so within the limits of that, where the profile deviated from the existing to where it matched up, that of course met 4R, and then outside of that, the rest of the project was 3R. So it is appropriate to do that in some cases. The key is to document it on the DSR and the Form 1002. You can put station to station, 4R, and then whatever alignment, westbound alignment, put 3R on that. So to document that and to let the field section know what the intent is.
Okay. All right, and a quick example here, actually, this is a 60% plan set that I looked at recently where it was obviously in a rural section, and again, the caution here is about mixing rural and urban, so this is where, like, part of it, because of some right-of-way and historical area constraints laterally, the design could not accommodate the proper shoulder width under 4R multi-lane rural criteria, so they just put down a curb because the urban street table says if you have a curb, you really don't need a shoulder. But they were advised that you really can't do that. It was technically a rural area, so even if you put a curb there, you still have to have the proper shoulder. In this case, it was 8 to 10 feet. After talking with the district and the consultant, they agreed that they're going to try to acquire more right-of-way and add the proper shoulders. And I think it's set up there. This is also near a middle school and a high school that I think the high school had at least 1,000 students, and we saw some evidence in Google Street View that they were riding their bikes on that shoulder, and you can see the posted speed there was 65. So again, just about, in this case, really making it safe for the students to get to and from school.
Okay, the
Chris, go ahead.
DSR, the Design Summary Report, it's required for all projects, and it will be integrated into TxDOT Connect. As we move forward with that, there'll be one standard version for all 25 districts starting out. And I know Brownwood District has one specific form, I guess, for smaller projects, a smaller form of the DSR. But right now, we're just going to have one standard version for 25 districts, and you can just fill out the applicable section.
Okay, now some considerations for filling out your 1002. Now, we haven't officially requested this yet, so that first bullet point's kind of grayed out there a little bit, that we may end up putting the 1002, since it has a lot of information that comes from the DSR that's being digitized. We're thinking it'd probably be a good idea to digitize the 1002 as well, although that's not official. Now, until it's official, you'll want to kind of pay attention to the rest of this. Fill in the roadway design manual, the chapter and the section, because again, the stuff that we're about to cover, the differences between 4R, 3R, 2R, you need to show, again, your engineering judgment on this document and communicate, like, okay, what are you designing to simply state under the criteria, the roadway design criteria, which is that second line in there, to simply state, we use the roadway design manual. That's really, in most cases, that's just not detailed enough, and we will comment on that to get you to add a little more to it. If you have multiple roadways on a project, you can submit multiple 1002 page 3s to avoid clutter. At the bottom there, you want to call out your design exception and waivers individually. Sometimes we see them all on the first line, but the reason there's multiple lines there, so you can break them out like they're shown there. And then you're encouraged with all your preliminary submittals to send the DSR and the 1002, again, until we integrate them into TxDOT Connect, is at that time, it'll be transparent enough to where we'll be able to access it directly in there. All right, now we're going to get into a quick discussion about the differences between 4R, 3R, 2R. Obviously, the first thing we're emphasizing in the little animation there is adding capacity, and that's the first bullet point here, and you can add capacity either through pavement widening or restriping. You'd have to make your lanes narrower, and obviously, and again, keep in mind, if you're just restriping that lane, could be a design exception case. We see those sometimes. If you're not adding capacity, but you're doing full reconstruction, again, 4R is considered reconstruction. So keep that in mind as well. If you're doing actual reconstruction, that would be 4R. bridge replacements not exempt under Chapter 6, Section 1. At the end, we'll talk about that. That's either replacing the entire bridge or just the superstructure. All interstate highways have to be 4R, and that includes your main lanes, shoulders, and your ramps. But preventive maintenance is also okay. So 3R and 2R, you wouldn't use that for interstate highway. Same thing for all other freeways. All the controlling criteria must meet the design speed, and then crash safety analysis is recommended to identify and address areas of concern. And there's just a summary of all the different parts of the 4R section, Chapter 3 of the RDM. I'm not going to read through that. Getting into 3R rehab, so one of our screenshots here in the middle there, that's a Super 2. We'll discuss that in a couple minutes. Although, again, I'll also mention the very next presentation is on Super 2, so we're not going to get into too much on that. And then the animation there just showing adding turn lanes, which is another thing that you can do under 3R. The purpose of 3R to preserve and extend the service life of existing highways and streets, to enhance safety. These are going to be non-added capacity projects, but you can widen the pavement. You can do bridge rehab as long as you're not adding capacity or replacing the bridge deck. You can do pavement rehab that's greater than 2 inches. Again, all the controlling criteria must meet the design speed. Minor changes to horizontal and vertical alignment are permitted. Significant changes are considered reconstruction. Again, that's one of those engineering judgment things. So if you're not sure, submit us a schematic, and we'll let you know if we think it might qualify for 3R. And again, on these, it's also true on 2R as well. You can add turn lanes, as we just showed, XL, decel lanes, or shoulders, and still be considered 3R, just as long as you're not adding any through lanes. Again, the crash safety analysis is recommended. A few bullet points here on Super 2s. And again, in the interest of time, we're a little short here. The next presentation is going to get into a lot more detail on that. There's a summary, again, of every part of Chapter 4, what all that contains. Final thing here, 2R restoration to restore pavement riding quality or other necessary components. Something specific about this to keep in mind. To use 2R, the roadway cannot be on the NHS. And again, that's one of those things you can use the statewide planning map to verify that. And then the current ADT should be less than or equal to 2,500 vehicles per lane. You want to do the crash safety analysis on these. Again, not added capacity, but okay to add turn lanes and shoulders, and then maintain your existing typical section and geometry as a minimum. And then Michelle actually found a pretty useful document here on federal aid design criteria, so go ahead and talk about that.
So a couple of things I want to point out in the federal aid to qualify for federal aid, the design criteria agreement that we have with FHWA. So on freeway main lanes, whether it's NHS, on system, off system, interstate, non-interstate, all design criteria is 4R or PM only. 3R is reserved on freeway corridors and interstate corridors for the frontage roads only. Another thing I want to point out is for 2R, 2R and PM on off-system roadways are not allowed. The only criteria that you can use on off-system roadways are 4R, 3R. On 2R, there's a little bit of a difference on the second sheet of this page that says ADTs of 1,500 max. Now this one, we'll have to check with FHWA on this to see if they're going to update this to match, well, if we're going to update our design manual to match theirs, which ours is 2,500 per lane, and they show 1,500 for 2R.
Okay, thank you. All right, real quick here, some advice on frontage roads, access control, and then also collector distributors. So here's just a summary of all where you find all frontage road design criteria, and specifically, let me call out the urban and the suburban, because if you look at the titles in parentheses there of those other tables, they're actually simply frontage road tables. But in order to get the proper criteria, and there's paragraphs in the manual that explain this, if I'm doing an urban 4R urban frontage road, I actually use the urban street table 3.1 and use the collector criteria. So just keep that in mind. If you have a project where in the scope of work, you're doing something to a frontage road and it's currently a two-way frontage road, you either have to convert it to one-way or submit a request to maintain it as a two-way frontage road, and that request should be submitted through the district to the design division director. Access control, So this is where you're basically showing on a schematic where you're not going to allow driveways and intersections, and this is usually it correlates to the locations of your on and your off ramp. So for an exit ramp, at the bottom there, figure 3-13, and then the middle table 3-16, that distance from the ramp to the next driveway or intersection is going to be anywhere from 460 to 1,000 feet. There is verbiage in the manual. 250 feet can be a minimum in areas of high driveway density, but again, that's one of those things where don't always design just to the minimum, and we may comment on it if we see that at every exit ramp you're just providing 250 feet. At an entrance ramp, it's 200 desirable, 100 minimum. Now, one of the comments from the panel here that they wanted us to clarify is if you look close, so it's this line that, the way it's shown right now, and it's got these 3 hashes, it kind of crosses the frontage road from the outside to the inside, but really the way that we accept it now is just to show it along the outside, because to me along the inside it's kind of obvious your only connections on the inside of the frontage road is probably going to be your ramps, and then maybe further down there'll be an intersection somewhere, but that same line for the intersection would be covered by the outside, so we may end up revising that. You only need to show it on the outside. And now a quick discussion about collector distributors. Curtis.
Yeah, going back to the how you show the access control, that was a memo out of right-of-way division several years ago. Just trying to make it much more clearer for the property owners so they can see exactly where the right-of-way was controlled. For collector distributor roads, we're designing a lot more of those in the Fort Worth district. We're getting up to 3, 4, 5 lane CD roads in some areas to split highways that were previously merged together. This picture shows a CD road for a normal cloverleaf interchange. So when I'm talking about CD roads, I'm thinking more from main lane to main lanes. We also have bypass frontage roads, which we've considered lower speed at the Fort Worth district from frontage road to frontage road. But for CD roads, higher speed, there's very little guidance in the RDM is what we found when we were trying to design them. And so we went to the TxDOT manual, and there's really only 2 guiding principles that we found even in TxDOT. One was that they shouldn't be designed for less than 10 miles an hour less than the main lane design speed. So that's a pretty large principle. And then also, it doesn't say what the minimum shoulder width is, but it recommends enough separation room for the same shoulder widths as the main lanes, and also a barrier. So for our larger CD roads that are several thousand feet long, 3 or 4 lanes, we're using 10-foot wide shoulders, just like main lanes. This picture here shows a CDs and a cloverleaf interchange system built in the 70s. So to update it to our standards or principles in TxDOT, you can see along the green lines is really kind of where the CD roads go, and there's up to 6% horizontal curves in a adverse crown. So really for high speed, it's only good for about 15 miles an hour. So it really wouldn't meet today's principles. So it is a lot more challenging in some of the compact urban areas to meet those principles. For you're going to have flatter curves, and you're probably going to have a super elevation on those. And really, it's more for safety and try to get your wider shoulders out there.
Okay, thank you, Curtis. And I apologize, everyone. Looks like we are about out of time, so I'm going to have to just go through the rest of these pretty quickly there. So, okay, obviously, quick animation here. Do not design your alignments like Mario Kart, because one of the things that makes Mario Kart fun is that it's unpredictable, but in real life, we want our alignments to meet driver expectations, be very predictable. And again, I'm sorry, I'm just going to have to click through these real quick. There's some tables in here. Again, this was intended, like we knew we couldn't do all this in 30 minutes. It was intended to be a reference that y'all could download and share. This is going to be, I think there's going to be a short course website set up where you can get this. Ken and I were talking. We're probably also going to put it on Design Division Crossroads page, so y'all can email me, and I'll send you all the link to get it there. Also probably our Design Division SharePoint. So there's some advice in here about how to read the horizontal alignment tables, do your super elevation, how to do proper super elevation and vertical profile through an intersection. It's actually somewhere near my house where they do kind of the double dip because of drainage, and if you're driving more than 15 miles an hour there, you're going to bottom out. So just advice not to do that. A little discussion on horizontal clearance. some advice on vertical clearance. And bridge division, they gave us a little info here on how to do proper alignment and other design elements on a structure. And again, another hyperlink there for that. And didn't have time to get into ADA accessibility and bicycle facilities. So I'll let, again, Pete's going to handle the rest of that later, so that's fine. But I did want to show, very last thing, let me click through all this, is, and then some other design criteria we had, off-system bridge replacement, and then preventive maintenance. I did want to show, again, you'll probably saw it, there were a lot of good hyperlinks in there, because again, the roadway design manual brings in a lot of other references, and particularly I'm talking to the younger engineers out there. If you download all of this and you have this in your arsenal, as a designer, boy, you're going to be like just really well-rounded, and you're going to do a real good job on all your projects if you're learning, again, not just about what's in the roadway design manual, but again, everything else that has to do with other parts of design and projects. So there's 2 pages of those links, plus all the bonus content that we talked about earlier. But again, our time is up. Apologies, we couldn't do more, but we're going to be hanging around here at 3 o'clock, so if you want to come down to the front and discuss any more of this, please let us know. But thank you all very much.